Hello! Thank you for your interest in learning more about psilocybin. This production was thoughtfully made by Roberto Arcia, Beau Chandler, Brylee Duncan, and Grace Hayden. In this presentation, we will be discussing psilocybin, the fungus that makes you hallucinate. Throughout this presentation, we will be discussing psilocybin, a substance commonly known as magic mushrooms. We will begin with an overview, dive into the physiology and brain circuitry, and end with possible long-term effects associated with the use of the substance. We hope that you learned something new from this educational video and appreciate the work that went into it. So let's start with an overview and answer the first obvious question. What is psilocybin? Psilocybin is a psychoactive compound found in certain mushrooms. The substance is best known for the psychoactive effects produced through stimulation of serotonin receptors. The 1960s is when these mushrooms started to gain the attention of many. In the United States, these mushrooms were widely used in experimental research as treatment for various mental disorders. As research was growing and producing promising results, the general public began abusing this substance. Shortly after, psilocybin became a Schedule I drug, and unfortunately, research was discontinued. Today, psilocybin remains an illegal substance, but is used in recreation by many. So now that we know what psilocybin is, let's talk about how it works. Psilocybin is an organic molecule that is naturally produced in fungus, specifically the psilocybin mushroom, which is more commonly known as magic mushrooms. Psilocin is a tryptamine compound, which is significant because the amino acid that produces serotonin is tryptophan. When digested in the body, psilocybin is dephosphorylated and turned into psilocin. Here you can see how similar of a chemical composition psilocin has to that of serotonin. Because of this, psilocin acts as serotonin would in neural synapses and causes there to be an abundance of interactions with the serotonin receptors. These serotonin receptors are also known as the 5-HT receptors. Therefore, we call psilocin a 5-HT agonist. This close resemblance to serotonin is what allows psilocybin to be such a potent drug. The amplified interactions result in psychological effects, most commonly hallucinations. But more on that soon. Okay, so now that we know what psilocybin is and what it does, let's move on to where this drug works within the brain. Let's begin by focusing on a singular serotonin receptor. As a reminder, we call these serotonin receptors 5-HT receptors. These receptors are densely located in areas of the brain, such as the prefrontal cortex, which is critical for cognitive function. Psilocybin causes psychedelic effects through the activation of specifically the 5-HT2A receptors, which is a subtype of the serotonin receptor. This is because the effects of psilocybin are negated when agonists are introduced to these receptors. And we know that the prefrontal cortex is responsible for things like mood and anxiety disorders. Therefore, when psilocybin is interacting with the 5-HT2A receptors, we tend to see things like mood change. Unfortunately, though, the exact molecular mechanisms of action are not fully yet understood. Within the field of research, there are some conflicting results about what specific parts of the brain are affected. In one study, PET scans found that people under the influence of psilocybin have increased metabolism in the brain, especially in the frontal cortex, while fMRI results showed that psilocybin reduces blood flow and neural activity in several brain regions, including the thalamus, posterior cingulate, and the anterior cingulate. This study was conducted by psychopharmacologists Robin Carhart Harris and David Nutt. David Nutt claims that he isn't sure why these results differ, but he theorizes that it may be due to the different time courses of the injectable drug used by his team and the oral tablets used by the other team. Shown are the fMRI results of David's study, in which the left and right hemispheres of the brain were observed. Here, we note that the blue regions of the brain had a significant decrease in cerebral blood flow when psilocybin was introduced versus the placebo. The noteworthy places of decreased activity are in the thalamus, posterior cingulate, and the anterior cingulate. So you may be asking, why is this important? Well, this is significant because reduced blood flow means less oxygen and impaired brain function. The two cingulate cortexes are two major connecting centers of the brain, and very important in functions involving internally directed thought, such as memory recollection. The impairment of these regions may explain why hallucinations occur while under the influence of psilocybin. In our next slide, we'll discuss where these brain regions affected are located. Alright, so let's review some of the data that was collected from David Nutt's research. To orient you on all of these graphs, the graphs on the left show cerebral blood flow through various regions of the brain. On these graphs, the x-axis is time, and the y-axis is the percent change of cerebral blood flow. The gray line is the placebo, and the blue line is psilocybin. From the top to the bottom, you are viewing the data for the thalamus, anterior cingulate, and posterior cingulate. The time that marks the moment of infusion is where the graph background switches from gray to white. This is where we notice significant variability in the data. You can see that as psilocybin is introduced, the blood flow is significantly decreased in comparison to the placebo. Now I'll direct your attention to the graphs on the right. These figures illustrate the relationship between blood flow and the intensity of the effect at various brain regions. You'll notice there are three parts of the brain highlighted, and I'm going to describe them. So from top to bottom, the first image has the thalamus highlighted, and it's shown to you in a horizontal plane, as if you were looking from the top of someone's head and down into the brain. The next two images are shown from the sagittal plane, as if you were looking into someone's brain from the side. The middle image is of the anterior cingulate, and the bottom image is of the posterior cingulate. And each of these images has a graph associated with it. On each graph, the x-axis is the intensity of subjective effects, and the y-axis is the percent change of cerebral blood flow both before and after psilocybin. These three regions of the brain present results that show an inverse relationship. We see as the intensity of the effects increase, the blood flow to these regions decreases. Together, this data justifies the claim that psilocybin decreases oxygen and therefore impedes the brain's ability to function. This could be the reason people hallucinate after consuming this drug. Finally, let's talk about health and psychology associated with the use of psilocybin. Well, the short answer is, we don't really know. There's still a lot left to be discovered. But here's what we do know. Although health and psychological effects can be very unpredictable between individuals, psilocybin has shown promising results in mental health treatment. Many who suffer from mental health disorders, such as major depressive disorder and PTSD, have reported long-lasting improvement in depressive symptoms after the use of psilocybin. This is likely due to the promotion of functional and structural neuroplasticity in the brain. Earlier we discussed psilocybin's effect on the prefrontal cortex, and studies show that there is usually no physical or neurological damage. With that said, it's amazing that the current data shows this therapeutic seems to suggest that there is no physical harm associated with the use of psilocybin. On the flip side, we do know of some complications that can occur with the use of psilocybin. Some of the dangers are the adverse side effects. This can include serotonin syndrome, which causes an overload of serotonin in the brain and can be fatal, and hallucinogen persisting perception disorder, which causes patients to experience flashbacks to previous trips while on the drug, whether they were good or bad. But to end on a good note, psilocybin may be a potential treatment for obesity. This is because the 5-HT receptors act upon modulators for food intake. But again, more research is needed in that area. And with that, we come to the end of our presentation. Thank you for your time and attention. We hope you found this video informative and interesting. This production was made as a research project for Dr. Zhang in neurobiology at the University of Missouri during the fall semester of 2022.